Hey guys, so we're gonna keep going now with looking at composition of these trig functions where we're working with things that are not on our unit circle. So all the examples that we saw in a previous video that you've been working on had values that you could be found on the unit circle. So we're gonna take a look at some examples now where that's not the case. So in your workbook on page 275, number 28, is the cosine of the inverse sine of 8 over 17. So cosine of the inverse sine of 8 over 17. So this we can't, I don't know off the top of my head what angle has a sine value of 8 over 17, but I can draw a triangle where I can find that. So this we're going to go back to our SOHCAHTOA and draw some triangles, and we're going to be drawing them in the coordinate plane. For this one, it's pretty straightforward and easy. So I've got in quadrant 1, I've got my angle theta. So sine is going to be opposite over hypotenuse. So this angle has a sine of 8 over 17. And then I will just use the Pythagorean theorem, or if I happen to recognize this is a Pythagorean triple, to find that last side. This is a Pythagorean triple. 8, 15, 17 is a Pythagorean triple. So there's my right triangle. And this is my angle, theta, that has a sine value of 8 over 17. And then I can look at my triangle and say, okay, what's the cosine of this angle then? My cosine is going to be adjacent over hypotenuse. So that's just going to be 15 over 17. So if you understood the kind of problems that we were doing before, these are pretty straightforward. You have to be careful though about drawing your angle and be paying attention to the SIGN sign of things. So we're going to flip back a page in your workbook now to page 273 and take a look at number 6. So number 6 on page 273. So we're taking the cosecant of the inverse tangent of negative 5/12. So we talked about how, you find that paper, when we're taking the inverse tangent and it's a negative number, so inverse tangent of a negative number, we're talking about quadrant 4 value that we're going to be looking at. So when we draw our triangle that we want for this, we're going to be drawing it in quadrant 4. So there we go. I've got my theta in quadrant 4, and there's my angle, and the tangent of that angle is negative 5/12. And tangent we know is opposite over adjacent. So my opposite is over here. That's my negative 5/12. And we'll go ahead and finish out your triangle again. If you recognize this is a Pythagorean triple, if not, you can do Pythagorean theorem. But 5, 12, 13 is a Pythagorean triple. So you've got make sure you have to be really careful where you put your positive and negatives. This is in our quadrant 4, we've got a positive along the x and negative along the y. So the negative 5 goes here. And now I want the cosecant of this angle. And remember that cosecant of x is the same thing as 1 over sine of x. And since sine of x is opposite over hypotenuse, the cosecant then would be hypotenuse over the opposite side. So our answer for this one would be hypotenuse over the opposite side. And with our negative, I don't like putting negatives in the denominator, so we're going to go ahead and just put the negative up top. So negative 13 over 5. That's my final answer for the cosecant of the inverse tangent of negative 5 over 12. Now let's look at one more example like this, where we are doing these composition of functions of trig values where we aren't looking at numbers that are on the unit circle. This one is also a little bit tricky. So this is page 273, number 7. Nope, I wrote that down wrong. Which number is this? Page 273. Number 8. Excuse me. Okay, so page 273, number 8. I also, to point out, on page 273 and 274, all of the places where it says arctan, arcsine, arccosine, we talked about this earlier in the year. That's just another way of saying inverse sine, inverse tangent, inverse cosine. It's just another notation for it. I prefer just doing the inverse, but all this has it with arc. You can pick which one you'd like. It's the same thing. All right, so number 8. So we have tangent of inverse sine or arcsine of -3/4. So with sine, when sine, we're taking the inverse sine of a negative value. That puts us down in quadrant 4. So we're going to draw our triangle for this in quadrant 4. All right, so there's my triangle, and I'm looking for this angle theta where my sine is -3/4. And all y'all better recognize that this is a special, or a Pythagorean triple. So opposite, oh, it's not. It's tricky because it's opposite over hypotenuse and not opposite over adjacent. So we do have to do Pythagorean theorem on this one. So opposite over hypotenuse. So be careful with this one. It is not a Pythagorean triple. So we do have to do Pythagorean theorem. So x squared plus our -3 squared is equal to 4 squared. You end up with x squared is equal to 7. X is equal to the square root of 7 for that last side of our triangle. So all of that work there. Just going through the Pythagorean theorem to find this last side to be the square root of 7. And now that we have that last side, now we can find the tangent of this angle, and the tangent we know is opposite over adjacent. So we have -3 over the square root of 7. And all y'all should be saying, wait, we can't leave a square root in the denominator, to which I will say, yes, you are right. We can't leave a square root in the denominator. So we will rationalize that. So we have -3 root 7 all over 7. I'll circle that to show. There's my final answer. This is number 8 on, this was page 273. So finding the tangent of the inverse sine of -3/4. All right, so I'm going to stop now and let you guys practice with this kind of problem. And then there's one more kind of problem. They'll have another video for that one. So hopefully that made sense. All right.